The Alchemist's Garden, a lesson in phytochemistry. The clock in the lecture hall chimed, signaling the start of the dreaded advanced phytochemistry, a course notorious for its impenetrable complexity. Yet, when the door swung open, it wasn't the expected dry, textbook-laden Dr. Eldridge who walked in. It was Professor Alistair Finch, a man known for his wildly unorthodox teaching methods and an enthusiasm for botany bordering on the theatrical. He wasn't carrying lecture notes or a laptop. Instead, he carried a strange assortment of items, a basket woven from thick vines, a small, steaming kettle, and a pestle and mortar resting on a deep purple velvet cloth. "Good morning, future plant whisperers," Professor Finch announced, his voice carrying the warm, resonant quality of an old radio host. "Today, we skip the PowerPoint. We're going to conduct a botanical heist. Phase 1, the crime scene, primary versus secondary." Professor Finch set the basket down. "Forget metabolites for a moment. Imagine a medieval castle, the plant. The castle needs basic functions to survive, right? Food, water, walls. That's primary metabolism." He pulled out a perfectly formed potato. "This potato is packed with starch. Starch is energy, the plant's basic bank account. That's primary. Essential for all plant life. Boring, but vital." Then, with a flourish, he revealed a sprig of intensely bitter wormwood, Artemisia absinthium. Now, the wormwood. It produces absinthin, a potent, intensely bitter compound. Does the plant need it to grow? No. Does it need it to fight off a ravenous deer or a hungry fungus? Absolutely. This is the secondary metabolite, the castle's alarm system, its hidden moat, its secret potion stash. These are the chemicals that make the plant unique, that give it its medicine, its flavor, and its toxicity. He placed the aloe on the table, then reached deeper into the basket. "Plants are amazing chemists," he said. "They make chemicals for protection, attraction, healing, and even communication. Let me show you something interesting." He pulled out a bright yellow lemon and held it up. "Why does lemon smell fresh and sharp?" "Because of limonene, another phytochemical. Limonene helps the lemon smell nice to humans but repels dangerous insects. And when we squeeze the lemon into water, that same limonene can help reduce inflammation and freshen our breath." He placed the lemon down. The basket was almost empty now. "So," he continued, "phytochemistry is not just for scientists in white coats. It's the reason your rooibos tea relaxes you, why your mother uses aloe on burns, why you feel refreshed after chewing mint, and why spices make food taste exciting." He clasped his hands behind his back and surveyed the room. "But to truly understand phytochemistry, you need to think the way plants do." The students exchanged puzzled looks. "We humans move around," he said. "We run, hide, build houses, put locks on doors, wear jackets. Plants cannot do any of that. So instead, they use chemicals." He began listing them on the board. "Colors, to attract pollinators. Smells, to attract or repel. Tastes, sweet to attract animals, bitter to protect themselves. Poisons, to defend against predators. Medicines, to heal themselves from damage. These chemicals," he said, tapping the board, "what phytochemists study. Not in a scary way, but in a curious way, trying to understand how plants survive and how we benefit from their strategies." At this point, the atmosphere in the room had shifted. Students leaned forward. Some smiled. A subject that once seemed complex now felt surprisingly relatable. But Professor Mark was not done. He opened a small glass jar and gently shook out a clove, a tiny brown spice. "This," he said, "contains eugenol, a phytochemical with a powerful smell. In plants, it acts like armor, protecting them from diseases. In humans, it works as a painkiller, especially for toothaches. If you've ever used clove oil for a sore tooth, you've used phytochemistry." He passed the clove around so each student could smell it. Next, he held up a chili pepper. "This one contains capsaicin. To us, it's spicy. To the plant, it's a brilliant defense mechanism. Capsaicin protects the chili from being eaten by mammals. Thabo laughed. But we eat it anyway. Yes, Mark said, chuckling. Humans are the only mammals crazy enough to enjoy the pain. But even capsaicin has benefits. It boosts metabolism, relieves pain, and improves circulation. Again, a plant chemical with human uses. By now, the students were fully engaged. The board was filled with colorful words: alkaloids, flavonoids, terpenes, phenolics, tannins. Yet somehow, none of it felt intimidating. Professor Mark stepped back from the board and folded his arms. "Let me tell you a secret," he said. "Phytochemistry is not about remembering chemical names. It's about recognizing patterns in nature. Everything plants do has a purpose. Every color, smell, taste, or reaction is chemistry in action." He walked to the window and pointed outside where trees swayed lightly. "Look at the trees. In summer, they are green because of chlorophyll. That's another plant chemical. In autumn, leaves turn yellow and red because other chemicals, like carotenoids and anthocyanins, become visible. Again, phytochemistry." He turned back to the class. "Think of plant chemicals like tools. Some plants use antioxidants to protect themselves from sunlight. Others use essential oils to fight fungi. Others use bitterness to stop being eaten. And we humans borrow these tools for our own health. Look at this," he said, holding it up. "Red, juicy, sweet. Why red? Why not blue or gray?" Some students shrugged, others looked amused. "This tomato is red because of lycopene, a plant chemical. Lycopene is a phytochemical, meaning a chemical made by plants. And this phytochemical helps protect the tomato from sunlight damage. At the same time, it attracts animals that help spread the seeds. Now, when you eat tomatoes, this same chemical protects your body too. It's good for your heart." He paused and smiled as a few students scribbled notes. So phytochemistry is about discovering what chemicals plants make, why they make them, and how those chemicals affect humans and other living things. He placed the tomato down and reached for the next item, a bunch of green mint leaves. The crisp scent immediately spread across the room. A couple of students inhaled deeply. "Let's talk about smell," Mark said. "Mint smells like mint because of a chemical called menthol. It's cool on your tongue and nose because plants created it to protect themselves from insects. Insects don't like the strong smell, it's like a natural bug spray." The class laughed softly. "And when we use mint," he continued, "that same menthol helps open our airways and soothe sore throats. Again, a plant chemical that helps both the plant and us." Thabo, a student known for asking unusual questions, raised his hand. "Sir, does that mean plants have pharmacies inside them?" Professor Mark grinned. "Absolutely. Every plant is like a tiny pharmacy filled with medicines, scents, colors, and flavors. And the study of these plant medicines is phytochemistry," the class chimed in. Mark nodded proudly. He picked up a small bitter aloe leaf next. "Now let's talk taste. Some plants are sweet, others are bitter. Why is that?" "To stop animals from eating them," another student suggested. A soft silence filled the room as students absorbed the idea. "Professor," Lorato said softly, "does that mean medicine comes from plants?" "Most medicines did at some point," Mark replied. "Aspirin started in willow bark. Morphine comes from poppies. Quinine for malaria came from tree bark. Even modern drugs often copy plant chemicals." He paused, waiting for the weight of that idea to sink in. "So when we study phytochemistry, we're studying the world's oldest pharmacy." He walked back to the basket and lifted it gently. "This," he said, "is nature's gift. But to use it wisely, we need to understand how it works. That is why phytochemistry matters." He placed the basket on a nearby table and pulled out the last item, a small purple flower. "This is lavender," he said. "Its soothing smell comes from linalool. For the plant, it attracts pollinators like bees. For humans, it relaxes the mind and helps with sleep." He closed his eyes for a moment, inhaling. "Plants speak. Not with words, but with chemicals. And when you understand phytochemistry, you learn to hear their language. The room was completely silent now. Even the students who usually scrolled on their phones were fully present. Professor Mark smiled softly. Science becomes easier, he said, when you stop memorizing and start observing. He placed the lavender on the desk and faced the class. So, he concluded, phytochemistry is simply the study of how plants use chemicals to survive, protect themselves, communicate, and help us stay healthy. He wrote one final sentence on the board. Plants are chemists. Phytochemistry is learning their secrets. A gentle buzz of excitement filled the room. Some students whispered to each other. Others flipped pages eagerly. The subject suddenly felt alive, far from the dry, complicated topic they had feared. As the bell rang, students gathered around Professor Mark, asking more questions.